Christian Keller.
Good afternoon, class. Can you hear me? Yeah, can you see the slide? Can you see the slide, please? Okay, class. Yes, today we will start with the method of solution. Yeah? Method of solution. So 3.4. The lecture note is available. Please check your lecture notes. There is one section we missed in section 3.3. That is inverse first translation theorem and unit step function. Unit step function or Heaviside function, 3.3, slide number 13. This one, you can check the new uploaded file, chapter 3. We will do that in the next lecture. The unit step function, or we call it Heaviside function, ut minus a. So today we will focus on methods of solutions. So all the lectures are recorded here. Please check. You can double check with that. Take piece of paper and then pencil with you, because you got to do some scribbling, check for the answers and the methods. So today we are going to solve the ordinary differential equation. That's why the title is method of solution. Meaning is you want to apply all these three. What is that? Laplace transform, inverse Laplace transform, and translation theorem. All these three we want to apply. That is one thing. Another thing is this method, this what we call Laplace transformation method, is an alternative method to solve ordinary differential equation. Meaning to say, you study chapter 1 ODE, separable, linear equation, exact, inexact, Bernoulli. Chapter 2, second order homogeneous, inhomogeneous equation, solving constant coefficient method, trial and error, to tackle the inhomogeneous part. And then the last one, chapter 2, is about Wronskian method to tackle the second order Bernoulli, Cauchy-Euler, sorry, Bernoulli is the first order. Cauchy-Euler, second order, and then constant coefficient, second order. You use Wronskian to tackle the inhomogeneous part. Okay, this is a little bit the background of this study. Now, question is, why we need Laplace transform? So Laplace transform, you see this slide, is to solve differential equation with the word, what we call the acronym, the notation IVP. So in the past, seldom you see the IVP problem, initial value problem, meaning you are given the initial condition. So hardly you see. So you leave your final answer in the general form with the constant C. Now, that constant C, you have to find. So this is one of the setback of the previous methods. It is not easy to find directly to constant C in your final solution. If you notice that all the second order, you find complementary solution, you have the C1, C2, or any constant A plus B for the homogeneous part. So this constant C, you cannot just leave it like that. You have to find what is the value of the constant C. So this Laplace is the name of the person. He discovered this method to solve this initial value problem directly. Directly meaning you don't have to find the C separately. That is one of the advantage of this method. So just to tell you a little bit on that, but as we go along with the slides, I will explain to you more detail. So at the moment, we want to know what is this method of solution. So method of solution, first thing, you must know the derivatives, because we are solving the differential equation using the Laplace method. So you must know the derivative of Laplace of the first derivative, dy dt. You say dy dx, but here we say df dt or dy dt, time variant. Yeah? So how do we define this? So you have to go back to the lecture 1, how we define Laplace of any function, sin t, cos t, Laplace of t. So this right-hand side is the definition from the chapter 1, beginning of chapter 1. All these are interconnected, yeah, strongly interconnected. You cannot separate 3.1, 3.2, 3.3 from 3.4. We cannot, because we are using the 3.1 to establish something new. So 3.4 is closely connected or related to 3.1. So without that, we cannot define the Laplace of f dash t. It is just a continuity of the previous section. So if f dash is called df dt. In our term, we say dy dx, but we don't use dy dx anymore. In this part, especially for the Laplace transform, we use dy dt, all the variable respect to t. So we are very much consistent with the original definition. So the Laplace of f dash t, you must know little bit integration by parts. So I'm not going into detail here about the integration by parts, because this is calculus. So anything to do with calculus, algebra, trigonometric, exponential function, it will take a long time to do the exercise. So I suggest you have to do it as a homework, because this is not the calculus course. This is not algebraic course. But we can give you some tips or hint. But it is your duty to go and do the exercise, because it's very lengthy. And it is not the right time to do integration by parts. No, it is not. But we can give you the formula, integration by parts, and you go home and you work it out. If you cannot get the answer that required, come back to us and we will clarify. Or you have any question, you can ask me at any moment now. So the Laplace of f dash t, according to the theory, formula 0 to infinite e minus st f dash t dt. This is the definition. So the integration by parts says uv, integration of u dv. You have to write the formula, because we are just quoting the formula. Integration of u dv as per what we have, but you can double check with the calculus book. U dv, integration of u dv equals to uv minus integration of v du. So in this case, your u is e minus st, your dv is f dash t dt. So this is e minus st v. Integrate f dash t respect to t, you get back ft, 0 to infinite. Minus v ft ds dt. So differentiate du. This u is e minus st. So minus s e minus st. S is the constant. T is variable. Yeah, remember s is the constant. So minus becomes positive here. But this thing come back to Laplace of ft. Remember, yeah, this thing Laplace ft. We no need to find. We are just writing the notation for Laplace of ft. This one you substitute minus infinite. Your t, this becomes 0. Minus your t0, this is minus f0. So this is just, we don't know the value, we just put it here. And this is sft. But Laplace of ft is fs. So therefore, you substitute Laplace ft, capital Fs. At the moment, we use capital F. Also in the previous lecture, we already told that the small f, Laplace of small f, big Fs. So now we created this formula. That is Laplace of f dash t s fs minus f0. If I write Laplace of y dash t, this becomes s f s minus f0 also. Sorry, Laplace of y dash t s capital ys minus y0. Sorry, you replace the f with y. Because normally, from now onwards, when you solve the problem, we don't have ft, we have yt. And Laplace of small yt equals to capital ys. You write down, yeah? Laplace of small yt equals to ys, capital ys. So we are doing the transformation from t domain to s domain. So this is one formula. But the next slide is missing here. Please forgive us. So it's okay because this slide is for the second derivative. You can see in your notes later. So you don't have this slide. Somehow or other the s f double t is missing. But anyway, the general formula for the f dash fn minus 1 if continuous on 0 to infinite and of exponential order if f and t is a piecewise continuous on 0 to infinity, then your Laplace of f and t, this is the general form. So I will give you for the second order, first order. This is a general equation. You don't need to memorize this, just get to know this. What you have to memorize is this formula. This slide 6 is missing. This one, Laplace f dash t. That means the n is 1. Now, if you substitute n1 here, Laplace of f n1, okay? If you substitute n1, you will get, you can do the testing now. You just test now. Substitute n1, so s n1 fs. But here, n1, 1 minus 1, 0. So s power 0, 0. So minus f0. So it stops there. So that's why the first equation, only 2 terms. You can check. You can check. Either you put n1 here, because n1 here makes sense, s power 0. n1 here cannot. So straight away you go here. If you put n1 here, n minus 1, 0. So this is f0. N1, f power 0, 0. So that is f0. That's why you have f0 here. F0, this one. So actually it comes from it comes from here. Now for Laplace of f2, if you substitute 2 here, you substitute now, n is 2 now. So we are finding Laplace of fn2 t. So you want to create the formula. So you will have s squared, write down here, fs minus s, this n2, 2 minus 1, 1. So s power 1, f0, then here, 2 minus 2, 2 minus 2, 0, s power 0, 1. So this one become minus f dash 0. So second order, you have three terms. That is s square fs minus s f0 minus f dash 0. The Laplace of ft is capital Fs. Now you have this formula. So this is s squared ys, that is capital Fs, minus f f0, this is y0, minus f dash 0. So Laplace of yt is ys, this one yt. So Laplace of dy dt, we create this from here, from this equation. This equation already proved. So you no need to prove this. So we just quote only. You use this and then you create this Laplace of dy dt sys minus y0. A Laplace of d squared y dt squared equals to s squared ys minus, this is capital Y, this is capital Y, capital Ys minus s small y0 minus y dash 0. Now for this, you see here, this is Laplace of d cube y dt square. So you substitute. In this case, n is 3. You go back here. So n is 3. N is 3. So n is 3. If you go back, f n 3. That is d cube y t dx dt cube. So n is 3. So s power 3 fs minus 3 minus 1, 2. 3 minus 1, 2. So s2 f0. Here 3 minus 2. 3 minus 2 is 1. And then the last one, fn minus 3. N is 3. 3 minus 3, 0. So this become f0, last one here. Not n minus 1. This is n minus 3, the next one. So you have f double dash 0. So f double dash 0, the last one. After f dash 0, you have f double dash. Because this is s power 0. sy dash, this one. Sy dash, this part. N is 3. The next one is f, after f dash, f double dash, n minus 3. So n minus 3 is 0, this one. So your Laplace of d cube y dt cube, s cube ys minus s squared y0 minus sy0 minus y dash 0. So all these y double dash 0, y dash 0, y0, all are initial condition. So if it's first order, you need one initial condition. Second order, you need two initial condition. Third order, you need 3 initial condition, like that. So our focus now is these 2 only. Okay, first order, second order. Of course, you no need to memorize this formula for the third order or fourth order. You will be given this formula. So from this formula, you can create any order, not only up to 3, 4, 5, and so on. So our job here is, we want to solve the Laplace, the method to solve ODE using Laplace transform. So Laplace transform is a constructed method. Well-constructed method is to solve the ordinary differential equation. So, how do we solve the ordinary differential equation? You see this figure, this is what we call the framework, the architecture of this method. So here, you see this is the differential equation. This is the differential equation. First order, constant coefficient. Homogeneous, non-homogeneous. Second order, constant coefficient. Homogeneous, non-homogeneous. So basically, this method is very suitable to solve constant coefficient linear differential equation. So the method goes like this. First, you see the yellow color box. First, we have to apply Laplace transform into differential equation. What is the meaning? We will show you an example later, how we take the Laplace of the differential equation. This is what we call, we Laplace the differential equation. That is the layman term. Now, once you take the Laplace of the differential equation, what will happen is, this is the problem. You see this box here? This is what we call the transformation of the differential equation to another domain, that is the ys domain. Just now you saw all ys term. You see here on the right hand side, all ys. Ys, 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 but y0, y dash, these are the initial condition. We will plug in the value inside here. So the variable is ys. So the ys is function in algebra. You see the word algebraic comes from algebra. So this ys, what is ys? It is an equation involve algebra. So algebra, of course, nothing to do with Laplace. This is what you have to do some investigation class. You have to think. This one is algebra, is not in our topic, but we need this algebra. Otherwise, we cannot solve the problem successfully or accurately. But you may say, can I do in other ways? This is what, this will be a big challenge for you. If you want to do any other way, all means can. But the major part is the Laplace. So here we are suggesting this way. That is, you create the algebraic equation in ys. Then you have to solve the transform equation ys using inverse Laplace. The symbol is this L power minus 1. This one is Laplace. You already finished. You already studied the Laplace of the functions. So you have to go back to 3.1, see slide 18. There are 8 equations given for Laplace. And then for the inverse Laplace, there are to be exact, 7 equations for inverse transform. 3.2, slide number 5. So this slide number 5 is very important, class, because without that we cannot do anything. Unless you memorize everything, but it will be very hard. And then this algebraic equation involves slide number 14 under 3.2. You refer to previous lecture notes. Inverse Laplace transform 3.2, slide number 14. The first column is form of the rational function. And then form of partial fraction. So the word the algebra, what they are talking here, this algebra, is basically about partial fraction. How to handle partial fraction? Finding the numerator, the a and b, c, d, and so on. And basically it involves the fraction, partial fraction. So we can show you one or two examples, but we cannot always show this partial fraction because this is very lengthy process. You got to do on your own. You just take a pencil or pen, just take piece of paper, you just scribble and then find the constant ABC, which we are referring to the 3.2, slide number 14, form of partial fraction. So there are 6 equations. The partial fraction, there are 6 equations for the 6 different types of rational function. So you have to match your problem with that rational function and then change it to a partial fraction. Then you find your output, that is your YT here. This block diagram is very simplified form, but the work, you got to do a lot of work because you may start at the inverse Laplace, or you wrongly put the Laplace transform, or you do not know how to decompose using the table 3.2 slide 14 about partial fraction. Partial fraction is the suggested algebraic method. But if you have any other method, you are most welcome. But whatever it is, the final answer YT must be the same. So we show you an example how to use Laplace transform. And all the table, including the partial fraction, and then the translation theorem, everything, 3.1, 3.2, 3.3. So now, you see this equation, I hope you can see. Any question class so far? Any question class so far? Before we move on to the example. Any question? Darren, Karen, Natasha? Okay, no question. Yeah, Derek. Derek Tan. Yes, Derek. Yeah. All right. So look at this example, please. And then make sure you have the initial condition. If you don't have the initial condition, we cannot solve this problem. So the word Laplace transform is very important. Use the Laplace transform to solve initial value problem. Initial value is this one. And this is initial value. When t0, yt0 equals to 6. Now, you already solved this problem, class. Just to let you know the background. This dy dt plus 3y equals to 13 sine t can be solved under chapter 1. Because this is linear constant coefficient, first order differential equation. First order. You can use the integrating factor. But in this current moment, you are not advised to use that method because of this Laplace transform. So we almost already finished about Laplace, inverse Laplace. The question is, can we solve this problem? Use Laplace transform, solve this problem, find your output, that is yt. This is dy dt plus 3y equals to 13 sine 2t. So we want to find what is the output. What is your yt? So you want to find the yt, the output. This is your output. Yt is what? So Laplace of dy dt plus 3y, you take Laplace of the whole thing. And this is the method, step 1. What you're doing in step 1, you are doing the transformation from t domain to s domain. You must remember, we are transforming the t variable to s domain. And then after that, from s domain, come back to t. First, you take Laplace, and then you take inverse Laplace. The return journey will be with inverse Laplace. Then you find your YT. So it's not easy at the moment. Look at this example. So you take Laplace left-hand side, Laplace right-hand side. So Laplace left-hand side, Laplace of dy dt plus 3, take out 3, Laplace of yt equals to 13, take out Laplace of sine 2t. Laplace of sine 2t, you go back to table slide number 18, 3.1. We call it table because normally this Laplace transform, they put it in the form of table. So in our lecture under 3.1, you refer to transform of some basic function. So according to the slide, it is slide number 18 under 3.1. If you look at 3.1 under transform of some basic function, you see equation number 4. Laplace of sine kt is k over s squared plus k squared. And k is here 2. So we can find Laplace of sine 2t from the slide 18, section 3.1. But Laplace of y is capital Laplace of yt, capital Ys. Laplace of dy dt, it is here, this one. So you take this one, and Laplace of y, you must use Ys. So we need only these two, this one and then this one. You need these two to plug inside Laplace of dy dt plus 3 Laplace of y. 13 Laplace of sine 2t. Laplace of sine 2t, the answer is 2 over s squared plus 2 squared. 4. That means 2 over s squared plus 4. So you have this. And now look this carefully. This one, Laplace of dy dt, according to the formula, sys minus y0. So you change Laplace of dy dt, go back. You see here, Laplace of dy dt, sys minus y0. So you copy this. You copy this and then put it here. So we need that table class. Sys minus y0. And then 3 over Laplace of y is ys, capital Ys. Equals to 13, you put it here. Laplace of sine 2t, 2 over s squared plus 4. So 13 multiplied 2, 26 over s squared plus 4. And this one, sys minus y0, 3ys, you write down first. Now, we have to replace this y0. What is y0? You go back to previous slide. Y0 is 6. So, now, you simplify again. So, when you simplify, sys minus y0 plus 3ys equals to 13, 2 over s squared plus 4. Sys minus y0 plus 3ys equals to 13 multiplied 2, 26. S squared plus 4. Now, sys minus y0. Y0 is 6. Plus 3ys equals to 26 over s squared plus 4. Now, this ys, you have to factorize. You take out ys. Now you have this term. This ys become s plus 3ys. So you just have to simplify. You just have to simplify. So s plus 3, you take this sys plus 3ys. You take out this ys, put it here. You take out s plus 3ys, and then minus 6 becomes 6, plus 26 over s square plus 4. So the minus 6 plus becomes 6 right hand side. Now ys you write as a title 6 over s plus 3, 26 over s plus 3 multiply s square plus 4. So all these terms you put it on the right hand side. So the left hand side only ys, because you want to find inverse Laplace of ys, because yt is Laplace of yt is ys. Laplace of yt is ys. Yeah, Laplace of yt is ys. So inverse Laplace of ys is yt. So you have to find inverse Laplace. So we are now going to find inverse Laplace of the right hand side. So this is the problem class, how to handle this part. And this is what we call the algebra. The algebra is how to handle this part. 6 over s plus 3 plus 26 over s plus 3 s square plus 4. So the way how to handle this is up to you, how you handle this. You can use many ways. Basically, we are referring to partial fraction. Partial fraction is available in table number 3.2, slide number 14. Form of rational function and form of partial fraction. Because there is no formula, direct formula to handle this part. This one maybe can, but still you have to handle this. So one of the method is we want to use the decomposition method. That means you decompose this into small pieces. That's why the table section 3.2 slide number 14 is given. Form of partial fraction. A over x minus a plus b over x minus b, a over x minus a plus b over x minus a square, and so on. There are 6 formulas given. Please refer to slide number 14, 3.2, inverse Laplace transform. So here, what they do, this s plus 3, s square plus 4, you simplify this. You simplify 6s plus 3, 26s plus 3, s square plus 4, you simplify. Now you take out your pen and pencil. This one divide by this, s square plus 4. So 6x squared plus 24. And then this divide by this one. So 24 plus 26 is 50. So 6s squared plus 50 is s plus 3, s squared plus 4. Now, if you want to take inverse Laplace of this, you cannot do it. You want to go back to this, it's up to you. But we already have this. This is the suggested steps. So if you want to follow this, then what we do, we have to do the decomposition. So we are looking for yt. Yt is inverse Laplace of ys. So if you take inverse Laplace of ys, you already found yt. But the problem is we have to solve this algebraically. This is what we call algebra. So algebra is about partial fraction. Now, this as 6s squared plus 50 divided by s plus 3 multiply s squared plus 4. How to write this form? That is the problem. So you go back to the table 3.2 inverse Laplace transform, slide number 14. I'm going to give you the answer. You have 6 equations. 1, 2, 3, 4, 5, 6 equations. The left hand side and the right hand side is the form of partial fraction. Now, this form, you see s squared plus 4. This one cannot be factorized in real number. So therefore, we are using equation number 6. Equation number 6. Tx squared plus qx plus r divided by x minus a multiplied by x squared plus bx plus c. Please refer, yeah? Where x squared plus bx plus c cannot be factorized further in real number, not complex number, in real number. So can you please refer to 3.2 inverse Laplace transform, slide number 14, previous slide. So using equation number 6, because this is s squared, this one is s squared, and this is s power 3, but this one cannot be factorized. Therefore, your partial fraction, this is now, we are writing the partial fraction, the ABC. A over s plus 3 plus bs plus c. This is ax, bx plus c. In the slide 3.2, slide 14, we use ABC. So here we use bs plus c over s square plus 4. So this one is bs plus c. Now, your A is 8. This is the problem. This one is algebra. Your B is minus 2. B is minus 2. Your C is 6. You see, they didn't show you how to find this. But we know from table 3.2, slide number 14, you obtain this. So the question is how to decompose this. So, class, now I'm giving you the value for A, B, C. How? You use simplify this s plus 3, s square plus 4, and then numerator as square plus 4 plus bs plus c s plus 3. So you will have 3 equations. You solve. This one you got to solve. This part, you got to solve this equation by partial fraction. You will obtain 3 equations. Equation number 1, 6 equals to, I write down, you solve now. I give you a time. A plus B. This one, we call it equation number 1. Okay, 6a plus b. You will have 3 equations. This is for s squared. Compare left hand side, right hand side for s squared. For s power 1, equation 2, you have 0 equals to 3b plus c. This one, we call it equation number 2. You solve this. 0 equivalent to 3b plus c. And then s plus 0, that is 50. You can see that already. 50 equals to 4a plus 3c. So this one, you solve these 3 equations plus. Now, you have time, you can solve. So a plus b, a is 8, b is 2. So 8 minus 2, 6. 3b plus c, 3 multiplied by minus 2, minus 6 plus 6, 0. 4a, 4 multiplied by a, 32, plus 3 multiplied c, 18. 32 plus 18, 50. So therefore, your a is correct. So your a, you must find this. A is 8. Your a is 8. Your b is minus 2. And then your c is 6. Any question, class, here? A is 8, B is minus 2, C is 6. Any question? Zoom in. Yeah. You solve 3 simultaneous equations. This is what they are telling about algebra. That's why they don't want to show this, because this is algebra. So normally algebra, they don't want to show. So you have to calculate. Are you agree with the answer, class? A, B, C? Hello? Are you agree with the value A, B, C? Okay. Okay. Thank you. Thank you. All right. Thanks. So that means you are with the subject. Yeah. All right. So now once you found the A, B, C, you see now here. So you have to do the decomposition. This one, you take inverse Laplace. Now you have to write inverse Laplace because you already changed YT. So YT is inverse Laplace of YS, left hand side. Left hand side is YT now. So inverse Laplace of 8s plus 3 minus 2s over s square plus 4 plus 6s square plus 4. So you have 3 decomposed fraction because we want to use the table. So the table I'm referring to is the inverse Laplace transform. So go back to table slide number 5 under section 3.2. So we don't have directly minus 2x plus 6. You have to rewrite minus 2s over s square plus 4 plus 6 over s square plus 4. So now we want to find this 8 you have to take out because no need. So this 8 you put outside and then inverse Laplace of 1 over s plus 3. Now inverse Laplace of 1 over s plus 3. Equation number 3, slide number 5, 3.2. Inverse Laplace of 1 over s minus a is E18, e power 18. So my a here should be minus 3 because the formula says s minus a. So if I put a minus 3, so inverse Laplace of 1 over s minus 3 is e minus 3t, this one. So there is no formula for s plus 3. That doesn't mean that you cannot use equation number 3. No, we must fit in this 1 over s plus 3 into 1 over s minus a because the formula for inverse Laplace of 1 over s minus a. So if you substitute a minus 3, then this is suitable for equation number 3. So the answer is e power minus 3t. Of course, the 8 is outside. Now, minus 2, these 2 take out, put it here. Inverse Laplace of s over s square plus 4. S over s square plus 4, you look at the table, equation number 5. Cos kt equals to inverse Laplace of s over s squared plus k squared. So this is cosine. Cos kt is inverse Laplace of s because there is s here. So in this case, your k squared is 4. You know k value cannot be negative. Therefore, your k is 2. So inverse Laplace of s over s square plus 4 is cos 2t. Kt, k becomes 2. So the final answer is minus 2 cos 2t. Plus 6, this one. You see this one, 6 you took outside. Okay. But if you want to put inside also can. But you must see which formula suitable to this. Inverse Laplace, if we take out 6 outside, then inverse Laplace 1 over s square plus 4. Inverse Laplace 1 over s square plus 4 is, we can use sine kt, the matching. You have to match with the formula number 4 with this problem. So sine kt equals to inverse Laplace of k over s square plus k square. So k squared is 4. Therefore, K must be 2. So you put here K2, then you have to adjust 6 divided by 2. So 6 divided by 2 will be 3. So therefore, 3 sine 2t. Sine 2t because K is 2. Now the final answer is yt. You must write yt equals to 8 multiplied e power minus 3t minus 2 cos 2t plus 3 sine 2t. If you have a term e minus 3t cos 2t sine 2t, you are almost 80% is correct. Because the others all are the constants, the numbers. The constants depend on the partial fraction. So you got to do partial fraction correctly in order to get this answer correct. Any question, class? Any question, class, so far? Especially this example, before we move on to the second order. Yes, Mohammed Dennis, yeah. Sumin, any question? Sumin. Some 3 sine 2t equals to cos equals 6. No. Mohammed Aikal, no, this one is wrong. 3 sine 2t equals to 6 cos 2. No. Mohammed Aikal, no, you are wrong. Sine, cos different, don't mix. Hello. Inverse Laplace. You go back to the table. I am referring to the table, please. 3.2, slide number 5, under inverse transform. Inverse Laplace transform. So, inverse Laplace transform S over S squared plus 4 is cos 2t. Inverse Laplace transform 1 over S squared plus 4, actually, this one is 1 over 2 sine 2t. So 1 over 2, because there is a 2 here, the 1 over 2 become 3. Not this one. No. This one is not correct. Mu is what? Mu. Can you reply mu to me? Can you, by voice, verbally? What do you mean by 3 sine t? 3 sine 2t equals to cos 2t. No. This one you got to find inverse Laplace. Inverse Laplace, 1 over S squared plus 4. You look at the table. Look at the table. Equation number 4. This one S squared plus 4. K is 2. So you put 2 here. If you put 2 here, you must divide by half 1 over 2. So the 1 over 2 sine 2t. But there is a 6. So 6 divided by 2 is 3. Yeah. Su mean, what do you mean by no? Mu. Are you okay, Mu? M-U, Mu. No, Mu. Oh, I got it, sir. Yeah. So this is the difficult part. This one some manipulation shortcut. So if you want to write properly, this one is half. If you use the formula number 4, the answer for this is half sine 2t of sine 2t. So 6 divided by 2, you can write here 6 divided by 2 is okay. But 6 divided by 2 is 3. 6 multiply 1 over 2, 6 multiplied by 1 over 2 sine 2t, like that. 6 multiplied by half sine 2t. So 6 multiplied by half is 3. This is the direct. But the inverse Laplace of this one, inverse Laplace of this is half sine 2t. So 6 multiplied by half or 6 divided by 2 is 3. Okay, class? Wei? One Amir? Are you okay? One Amir? Wei? Yong Wei? Are you okay? Yao Kong? Are you okay? Ip Yang? Ip, okay? Thank you, Yung. Thank you, Yung. Okay, Yao Kong, okay. About slope, but just need to revise. Yeah, yes, yeah. You have to go slow. Yeah, you have to do it many times. It's very hard at the first time. So if you want, you have to practice, then it will become very easy for you. So this is just the beginning. Try and error. No? Why try and error? Muhammad Amir. Muhammad Amir also move. Move. Another move. We have 2 more. Muhammad Aikal also move. Muhammad Amir. No, not try and error. No. This one, you got to practice. The formula is available under the section 3.2, slide number 5. You have 7 formulas. 7 formulas. So refer to the 7 formulas class. So now, thank you. Yeah, good. Go and study, yeah? Okay, so you can revise later. Now we move on to second order. This is quite interesting problem. So you see this equation, please take note, yeah? Y double dash, that is d squared y dt squared minus 3y dash dy dt plus 2y equals to e minus 4t. This one is second order linear constant coefficient inhomogeneous differential equation with the initial condition y0 equals to 1, y dash 0 equals to 5. So this one can be solved using undetermined coefficient method, or you can use Wronskian method. But since the function, the right-hand side inhomogeneous e power minus 40, you can use undetermined coefficient method. But the problem with undetermined coefficient method, you must find the C. And you have to find the YC first, then YP next, and then combine together, and then find the C. So if you notice in Laplace transform, with the first order, there is no C, constant. First order, at least you have one constant. So the constant, it's already done in the problem itself. So Laplace transform, it takes care the unknown constant. If it's second order, you have two constants, C1 and C2. That is the major problem with the previous methods, such as undetermined coefficient method, even Wronskian method, also the Euler-Cauchy. So one of the best way to get rid of finding the C1, C2, especially for the second order, is to use Laplace transform. But it must be constant coefficients. So now, with the initial condition y0, 1, y dash 0, 5, we take Laplace of this second order. Laplace of y double dash minus 3y dash plus 2y equals to Laplace of e power 40. Now you must know Laplace of y double dash, Laplace of y dash, Laplace of y, Laplace of e power 40. You must know. Where do we get? For the left-hand side, you must go here. Sorry, you go to this table. Laplace of y is ys. Okay, so you use this one. Laplace of y, ys. Laplace of dy dt, sys minus y0. Y0 is given. Laplace of d squared y dt squared equals to s squared ys minus sy0 minus y dash 0. This one given, this one also given. So you can substitute these values. That's why the initial conditions are very, very important, because you can substitute the value and then you solve the problem. So here, Laplace of y double dash is s squared minus sy0 y dash 0 minus 3 outside in the bracket, Laplace of y dash sys minus y0 plus 2 Laplace of yt is ys, and Laplace of e power minus 40 from the table. So we are referring to the table number slide 18, 3.1. So Laplace of EAT is 1 over s minus a. So your a is minus 4 here. So 1 over s minus 4 is 1 over s plus 4. So this is Laplace of e power minus 40. Now, this one, you are just removing the bracket, and then later we simplify. S squared ys minus sy0 minus y dash 0 minus 3 sys minus 3 y0 plus 2 ys 1 over s plus 4. Now this ys you collect. And then this y0, y dash 0, y0, you fill up the values. So what happens next is, now this one you got to do slowly. This s square ys, sy0, y dash 0, 3 sys, minus plus 3 ys, plus 2 ys, 1 over s plus 4. Now, s squared ys, you leave it. Y0 is 1. So Y0 is 1. y dash 0 is 5. Minus 3sys plus 3y0, 1. Plus 2ys equals to 1os plus 4. Now, s squared ys, you leave it as it is. Minus 3sys, you're collecting the ys plus 2ys. The rest, minus s here, minus 3 plus minus 5 plus 3 minus 2. So you want to bring this from left hand side to right hand side. Because left hand side, you must have only ys. So you do the grouping for ys. So ys, you take out s squared minus 3s plus 2. And then minus s minus 2, you bring right hand side, becomes s plus 2. So 1 over s plus 4 plus s plus 2. Now this term, you cannot leave it here. You must bring right hand side. Because this is s domain factor. So the algebra is ys. Last time we called capital Fs. Capital Fs is algebraic equation. So this is the algebraic equation. 1 over s plus 4 divided by s squared minus 3s plus 2. And then plus s squared s plus 2 divided by s squared minus 3s plus 2. Now this one you can simplify. This 2 you must make it 1. How? Denominator s plus 4 s squared plus 3s plus 2. This divided by this 1. And this divided by this s plus 4 multiply s plus 2 s squared plus 6s plus 8 plus 1 9. So s squared plus 6s plus 3 plus 9, sorry. Divide by s plus 4. This s squared minus 3s plus 2 you can factorize. How do we factorize? S minus 1, s minus 2. You may say, can I factorize this? Not necessary. This is actually s plus 3 power 2, but no need. Because we want to do decomposition. How to decompose this? Now, this ys is this. This is the algebraic equation they are talking about. Now we want to decompose this. In order to do inverse Laplace of ys is yt. So in order to do inverse Laplace of this, you go to the table. The table is in 3.2, slide number 14. So, form of rational function 1 to 6, form of partial fraction right hand side 1 to 6. So, we have 6 equations. Out of 6 equations, equation number 3 is correct to solve this problem. So, you see equation number 6, that is equation number 3, that is px squared plus qx plus r divided by x minus a, x minus b, x minus c. Equation number 3. A not equals to b, b not equals to c. So, s plus 4, this is x minus a. S minus 1, this is x minus b. S minus 2, this is x minus c. So, you have yt is inverse. Now, yt is inverse Laplace of ys. So, you have to write this term a over s minus 1 plus b over s minus 2 plus c over s plus 4. So, you got to write this. Now, this a, b, c, they already found. How they found? Using the partial fraction. So we cannot, it was not shown here. The reason is, this is algebra. So in algebra, of course, algebra is different from ordinary differential equation. So you cannot, expect they will show you how to find ABC. So now is your turn to write a over s minus 1, write down here, plus b over s minus 2, plus C over S plus 4. And then you do the factorization. S minus 1, denominator S minus 2, S plus 4. So you have A, S minus 2, S plus 4, plus B, S minus 1, S plus 4, plus C, S minus 1, S plus 2. It is up to you how you do. That's why they didn't show you. You can do any method as you like. Any method as you like. So you have AS squared, 4 minus 2S, 2S minus 8, plus BS squared, 4 minus 1 plus 3S minus 4 plus C S squared minus 3S plus 2. So you equate. You equate left hand side, right hand side. The square, S squared. S squared is not 1, the constant. S squared, 1S squared, left hand side. So you have A plus B plus C. A plus B plus C equals to 1. So you test 16 over 5 plus 25 over 6 plus 1 over 30. So 30 divided by 5, 6. So minus 96 plus 5, 125 plus 1. So minus 95, 125 minus 95 is 30. So 30 over 30 is equals to 1. So correct. So you should get class, I write down here. So if you solve this, you must have equation 1, that is S squared, with 1 equals to A plus, according to this method, I am solving using the partial fraction. So this is equation number 1. Okay? Now, for S power 1 is 6. So S power 1, you have 2A, 3B minus 3C. So 2 multiplied by A minus 16 over 5 plus 3 multiplied by B 25 over 6 minus 3 multiplied by C 1 over 30. So minus 32 over 5 plus 75 divided by 6 minus 3 over 30. So 30, this is 6. One nine two plus 5. 5 375 minus 3. So 375 minus 195. 0, 8, 180 divided by 30, answer is 6. So correct. So second equation is S. 6 equals to, you do it here, please try, 2A plus 3B minus 3c. And this is second equation. 6 equals to 2a plus 3b minus 3c. So you try to solve. A, B, C. This is A, this is B, this is C. Now the third equation, S power 0. S power 0, 9 left hand side. So minus 8A minus 4B plus 2C. So you simplify. 9 equals to minus 8A minus 4B plus 2C. Minus 8A minus 4B plus 2C. So minus 8A minus 16 over 5 plus 4B 25 over 6 plus 2C 1 over 30. So one to 8 over 5 minus 25 100 plus 2 over 30. So you have 30 divided by 5, 6. So 768 minus 300 30 divided by 6, 500 plus 2. Seven, 6, 8 minus 500, 8, 6, 268. 268, 270 divided by 30. So you will get 9. Okay. So if you solve these three equations, class, you should get your A equals to minus 16 over 5. This is your A. And then B equal to 25 over 6. And then your C equals to 1 over 30. So you solve the three equations. First one is S power 2. Second one is S power 1. Yes, yeah. That's what I'm telling. So we can also find the same answer. Okay. Okay. Good. Okay. No problem. You can do that. Yeah, that is easy way, shortcut. Shortcut method. You substitute S equals to X equals to 1 minus 4. S minus 4. Yeah. You substitute S minus 4. S plus 4, 0. You substitute S equals to 2. S minus 4. S equals to minus 4. S equals to 1 and S equals to 2. So answer must be the same. All right, Chia. Okay, Chia. Okay, you can work on that. Now, once you have this, that's why this one is tedious. But you can do the shortcut as you substitute S minus 4. Sorry, S minus 4, S1, S2. Now, you take inverse Laplace. So, inverse Laplace minus 16 over 5, this one is a constant class. So you take out. Don't let constant disturb this inverse Laplace. Inverse Laplace 1 over S minus 1. Don't worry. All the numbers you put outside. Plus 25 over 6 you take out. Put it here. And inverse Laplace 1 over S minus 2. Write down. Not full form, yeah? But don't worry. Don't worry about the numerator or denominator. Later we will adjust. And 1 over 30 you take out, put outside. Inverse Laplace 1 over S plus 4. This is inverse Laplace. In order to solve this, don't worry about the constant, yeah? The inverse Laplace, you go to the table. You go to the table, inverse Laplace table. Inverse Laplace table is at slide number 5 under section 3.2. So we have to refer to section 3.2 class. Very important, yeah? Section 3.2 under inverse transform. Under inverse transform. Under inverse transform, you have inverse Laplace of 1 over S minus A. Exactly same. Your A is 1. So, inverse Laplace of 1 over S minus A, my A is 1. So, answer is ET. Minus 16 over 5, you just leave it. So, the answer for inverse Laplace 1 over S minus 1, answer is E power T. This is very important. Minus 16 over 5 is nothing to do with the inverse Laplace. It's just a constant. You put the constant outside. Similarly, 25 over 6 is outside. Inverse Laplace of 1 over S minus 2. Again, inverse Laplace 1 over S minus A is EAT, equation number 3. Under 3.2, inverse transform. Under inverse transform 3.2, EAT equals to inverse Laplace of 1 over S minus A. Your A is 2 plus. So therefore, inverse Laplace of this E2t, E power 2t. Your A is 2. Plus 1 over 30, inverse Laplace of 1 over S plus 4. The whole thing, this one. 1 over S plus 4. Again, inverse Laplace of 1 over S minus A is equals to EAT. So I substitute A minus 4. So S minus 4 is E power minus 40. This one. 1 over 30 is outside. So the final answer for this YT is the whole thing. Minus 16 over 5 ET plus 25 over 6 E power 2t plus 1 over 30 E power minus 40. Okay, so this is the final example. Now, today we just do this one only, but unfortunately the next slide, these are the example. I don't have the answer at the moment. You can try. And then in the next lecture, you can come back to me or you can email me about the solution, or about any difficulties. So example 3, use the Laplace transform to solve the IVP. Y dash plus 2y equals 0, y0 equals to 3. This is what we call IVP. IVP meaning initial value problem. So this one is first order. You take Laplace of this, Laplace of the whole thing, yeah? Laplace left hand side and right hand side. This 0 is t power 0, no? Laplace t power 0. Laplace t power 0 is 1, but this is 0. So Laplace of 0 is 0. Now use the Laplace transform to solve the following IVP. You take Laplace both sides, entire differential equation, Laplace, entire differential equation, and then use Laplace y double dash minus 7 Laplace of y dash plus 10 of Laplace of yt equals to 4 of Laplace multiplied by Laplace of E3t. Laplace of E3t, you know, you can get it from the table and use this condition. And the last one is y double dash plus 9y equals to e power t. There is no y dash, don't worry. Laplace, take Laplace of the whole thing. Laplace of y double dash, Laplace of 9 Laplace of yt plus Laplace of et. And then form all ys equation, substitute this initial condition, and then solve the algebraic equation. Just now you want to do algebraic equation in a different way, it's up to you how you do it. You can use substitution method or any method, partial fraction, and that is where you will be caught. But again, if you still use the table, even your constant is wrong, it's okay, because that constant comes from algebra. You must refer to this class. You see the process, the framework already clearly explained how the starting point and the ending point. You see the word algebra. This is the ys. The ys is the algebra. But you must get out from ys into yt. That's why you need the inverse Laplace. So this inverse Laplace is you are transforming ys to yt. So without inverse Laplace cannot. So that's why the inverse Laplace is very important. Okay. So what is important for today before I stop? Yeah. So the important thing is, so if you revise this thing back, so I show you which slide is very important. So the most important thing is, of course, this is the general knowledge, the framework, the structure, how it works. This table is very important. I call it table. Of course, they put it this form. So this one is very important. You must know how to get this from here. From here, from this one, how to get this. If this one given, of course, you just copy. But if this one given, you derive yourself. This is the general formula, very powerful, because this is the theorem. From theorem comes the method. So from here, they got it here. So you must have this. Without this, cannot. So this is very important. Slide number 8, right? Remember, yeah, slide number 8, this is very important. And then this formula, slide number 7, very important. And then this one, of course, slide 6. Slide 6 is about this. You can check. I'm using another thing, another notes, but you can see in your notes, this is the formula for slide number 6. Missing, right? Empty. I'm sorry about that. And this one is the equation number 1, how they derive. This one is the proof. But you see in the last when you solve the problem, you no need to do this. You just need this one only. That's why you need that. So the important thing is here, of course, now we already come to the end. So the final goal is you have to solve this problem, otherwise cannot. So what we are talking about is this one, all this. So before you solve this, because this is the last slide, you must know the previous slides. I already mentioned to you, the previous slide is 3.1. Because it is inside 3.1, so I cannot show you here, copy and paste, because it is in 3.1, slide number 18. So if you go to slide number 18, under 3.1, you can see transform of some basic function. So you have 7 equations, such as Laplace of 1 over s, Laplace of t power n factorial Sn plus 1, Laplace of EAT, 1 over s minus a, Laplace of sin kt, k over s square plus k square, and then Laplace of cos kt, s over s square plus k square, and then Laplace of sin kt, k over s square plus k square, Laplace of cos kt, s over s square plus k square. So you have to remember that. And then you have inverse Laplace, that is 3.2. So 3.2 inverse Laplace under inverse transform, slide number 5 of 14 slide, that is 7 equation again. 1 equals to inverse Laplace 1 over s. All this you no need to memorize. You just have to refer only. Tn equals to inverse Laplace n factorial Sn plus 1. You have to do some modification in order to find the answer according to the problem. Equation number 3, EAT equals to inverse Laplace 1 over s minus a. Equation number 4, sin kt equals to inverse Laplace k over s square plus k square. And then equation number 5, cos kt inverse Laplace s over s square plus k square. And then sin kt inverse Laplace k over s square minus k square. Equation number 7, cos kt equals to inverse Laplace s over s square plus k square. You must be familiar with this and you must quickly refer to this. Otherwise, we cannot find inverse Laplace. So these 7 formulas, including hyperbolic formulas, sin and cos, you must be very familiar. And then the last one is the inverse Laplace transform 3.2, slide number 14. There are 2 columns. The first column is form of the rational function. Second column is about a form of partial fraction. Equation number 1 up to equation number 6. Equation number 1, px plus q divided by x minus a multiply x minus b, a not equals to b, equals to a over x minus a plus b over x minus b. Equation number 2, px plus q divided by x minus a squared equals to a over x minus a plus b over x minus a squared. This is a repeated rule. Equation number 3, px squared plus qx plus r divided by x minus a, x minus b, x minus c. A, b, c are all not equal. A over x minus a plus b over x minus b plus c over x minus c. And then number 4, px squared plus qx plus r divided by x minus a squared multiply x minus b, a not equals to b, equals to x a divided by x minus a plus b over x minus a squared plus c over x minus b. And the number 5, this one is important as well, px squared plus qx plus r divided by x minus a cube multiply x minus b, a not equals to b, equals to a over x minus a, b over x minus a squared plus C over x minus A cube plus D over x minus B. And then number 6, this is the most important one, px squared plus qx plus r divided by x minus A, x squared plus bx plus c. But the bx plus c, x squared plus bx plus c cannot be factorized. If it can be factorized, then it goes to equation number 3. Cannot factorize, equation number 6. You see 3 and 6 almost similar, but you have to watch the x squared plus bx plus c, which cannot be factorized in the real number system. Therefore, the answer is A over x minus A, capital A over x minus A plus bx plus c divided by x squared plus bx plus c. So this 6th equation is called the partial fraction. That is what mentioned in the framework, the algebraic form. So either you memorize this table, form of partial fraction, or just quickly you can refer. Without that, the example 3, 4, 5 is very hard for you to solve. So that is the summary of this. So next class, we will do more example. Let us see discussion on some questions so we can solve some of the problems, more exercises. But today, we don't have any more unless you have any questions. Any question, please? Any questions so far? So those of you want to solve the tutorial question, you can solve. And we already put the instruction on the ULearn. And quiz 1, those of you who haven't done, please email me. We will send you a question via email. So please, those of you who missed the quiz 1. So those of you already done quiz 1, no need. So those of you who missed the quiz 1, please email me. So is there no answer for tutorial? For tutorial, I'm sorry. Please contact your tutors according to the program. Please contact your tutor, discuss with them. Please refer to ULearn. For the email. So we have now we have I think remaining 1, 2 or 3 tutors, 3 of them. But you can email them, and then you can CC to me if you want. Refer to ULearn for their emails, and you can discuss with them. Yeah, Muhammad Amir. Is there no answer for tutorial? Actually, we don't give you the answer like that. It's just based on discussion, because in our timetable, there is no such thing specifically mentioned about tutorial. We have 4 hours lecture, mechanical group. Today we are already done, and next one is on Wednesday. So you just have to discuss. This is informal class. Officially, if you look at the timetable, we don't have. So in your timetable, you have lecture 1, SC1, mechanical engineering, 12 to 2 today. And Wednesday, mechanical engineering, FEM 1023, lecture 2. So there is no tutorial. So I'm sorry about that. But the tutors, they are willing to help you. So you can email them and then CC to me. So if you have any problems, you have to forward to me via email. and then you can ask at the lecture time, like this now. I give you a rough idea, I give you some hints or tips, you can work it out. You have any suggestion, please, you can share with all of us here, especially the answers. If you want to check your final answers, you need not do all the tutorial question. You see there are tutorial question uploaded by the coordinator. You just pick few problems and you try to solve whenever you are free. So no need to push very hard. Just second order, take 2-3 questions, homogeneous, non-homogeneous, use the method. We are going little bit on ahead schedule-wise. This is we are running 5th week. Hopefully this week we will do the assignment, online assignment. We are trying. Okay, but I will let you know. Please bear with me. If there is a quiz, I will let you know at least 1 or 2 days before, so that you can prepare, and then you can see in the ULearn, because there is no information. Only the information is straight away directly go and do the quiz. The assignment also we are planning via ULearn. So I will let you know once the assignment question is uploaded, hopefully this week. But we prefer on Saturday morning or afternoon or evening. If you cannot make it, you just have to let me know. If your computer is having a problem, please let me know. And we will revise all this, and the lectures notes are there already and recorded as well. So there is no issue. At the moment, I prefer this is the best way we can do. If you have any problem, I know some of you already emailed me. You just wait. We have to prepare the question for you. The re-quiz, I think about 5 students, not more than that. Your group and the other group, but we will email. It will email and you have to reply before that time period given. It's not like in the ULearn, yeah? It is via email. So the re-quiz is via email. Okay? So any question, class, before we start? Thanks a lot. And then we stop here. If you have any question, okay, good. So if you understood very well, take your time. 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 Please revise. The keyword is revise. You can do it slowly. Please revise and practice. So even your answer is wrong, but your method is correct. You saw the framework, right? You see in the framework, the block diagram. So how you go take Laplace, and then you create all the YS system and solve the algebraic and take the inverse Laplace transform and then get the YT. It's very interesting. But if you want to check, okay, if you see this answer, if you want to check this answer correct or not, it's very hard. But you can do. You go back, substitute inside this equation. You substitute inside this equation, the right hand side must be e power 40. This one, class, is not given. You see this block diagram. You go here and then go here. From here, go here. But from here, how to go here? That is the biggest challenge. This is what we call we verify. So you complete this circle, 360 degrees. How to do this? So from here, you can test whether this answer is correct or not. But this will be very, very hard for you. Because to test, first order, okay. If you want to test this, okay, no problem. You take your y, you already got y. You see, you already successfully solved. This is your y class, output, right? This is output. You differentiate dy dt, you put inside here. You put inside here dy dt, and you put y inside here, you get 13 sine 2t, that means your answer is perfect. That's how, but that one is here. Here. This part class. So I'm joining this here. This one is the last part. But normally we don't do this. We don't do this part because this is something like you verify. You believe. You strongly believe that your answer is correct or wrong. But we don't do this. As far as you get this answer, you are happy. As far as you get this answer, you are happy. Because this is very long. 1, 2, 3 terms involved sine cos. Okay? All right. See you then, class. All the best. Please fill up the form. All the best. Please fill up. Please fill up. Fill up the satisfaction code. And then satisfaction code. Please fill up the satisfaction and SSRT SSRT via U campus IP. Yeah. Yes. Any question? Yes. Satisfaction pool via ULearn, yeah? Yes. Satisfaction pool via ULearn. Yeah, any question? Yeah. Tumin Purushothaman. Are you there, Purushothaman? Purushothaman. Yes. Okay, thank you. Thank you, sir. Thank you. Okay, so that's all for today. Thank you for your time. See you in the next class. If any question, you just